We're doing all that.
Yeah. Alright, so our physics problem. The height in meters of a projectile shot vertically upward from a point 2 meters above ground level with an initial velocity of 24.5 meters per second is this equation. H equals 2 plus 24.5t minus 4.9t squared after t seconds. So part A, find the velocity. So walk us through this, guys.
Okay, so first you gotta take your equation, like the h equals 2 plus, and you find the derivative for it.
Okay, because we know the height is like your position function. Velocity just means first derivative.
And then you just plug in your 2s or your 4s for t.
What did you do with the square that was on the
That's not a 4.9 anymore, is it? Isn't it a 9.8?
Oh, I wrote the wrong thing down.
Scratch it out.
There we go. Boom.
Okay, can I see your work? Your work. So the next one. I don't know what we're doing now. We're maximum height. Solve for t.
Are you guys all following this so far? Maximum height. So what they did is they set the derivative equal to 0. A couple ways you could think about this. The derivative represents velocity, right? So you're going to have your maximum when you were going up and you switch to going down. So at that second where your velocity was 0. Or you could think of it in terms of a graph. If you have a curve, we know the highest point has a horizontal tangent line. So the derivative equals 0. Yeah, you're writing. You wrote 4.9 again. Change that to that's a 9.8. You have the right answer, but you keep writing the wrong number.
That was all in my head. So that's why.
I'm blind. Which one's this one? Huh? That one? Alright, then for C, you plug in your 2.5 that you got on B for your T. And I wrote down the wrong thing again. What is that? Because I think I got the wrong thing. What you get?
I just wrote down what you have.
No, I'll definitely put it.
You guys can help them out in your seats. Plug it in, help them.
Oh, it's 0.
And you should plug it in, not to the derivative though, right? We want the actual maximum height. You found the time when you have your maximum, so to find the height, you have to plug that.
You just plug it into the original?
Yes. plug the 2.5 into the original.
It's 32 something.
32 point.
65.
Mm-hmm.
It's 32. And then for the next one, you just solve for t on the first thing. Solve for that, and you get 5.
To solve this, you have a couple options. You could do like the quadratic formula. You can also look at a graphing calculator and just see when it hits the ground. It's actually like 5.08 if you keep a couple decimal places. So you can find out exactly a couple different ways.
Alright, before this, do you plug that into the derivative or do you plug that one into the original?
You want the velocity, so you plug it into the derivative.
Okay, good. It's 9.8, right? Oh, it is?
Derivative.
Yeah, it's 4.9. I don't know why I do that. Or why I thought.
It's 0.
You got 0?
Well, no, I think I know what it is.
Negative 24.5, yeah. If you did it exactly and had the 5.08, when you plugged it in, you got like negative 25.284. So on your homework, you might try to keep a couple more decimal places just for accuracy purposes. That's a velocity, so it's meters per second. Okay, so that's our physics problem. We've done something similar to that, just usually not all within one problem. Those are all kinds of things that you've been asked, but maybe not all at once before. All right, are we okay with that one? Any questions about it? Okay, let's go to our chemistry problem. So it's talking about Boyle's law. Boyle's law states that when a sample of gas is compressed at a constant temperature, the product of the pressure and volume remain constant. P times V equals C. Part A wants the rate of change in volume with respect to pressure. So we're asking you to find the derivative of volume where pressure is your variable. Okay.
First thing we did was bring the P over, and then we found the derivative and used the quotient rule. And then we solved for the derivatives.
So C here represented a constant. That's how they know its derivative is 0. The derivative of P is our variable. It's just P to the first power. So when you do the derivative of a variable to the first power, it's just 1. Just like the derivative of X is 1. So overall we get negative C over P squared for this derivative. Are you guys all clear on that part?
For B, you just took this equation and we thought about it. So C is constant, and then P, it said that it would gradually increase. So you just assigned it a value first, and then as time goes on, you get higher P values and they get smaller. So your number would get smaller. So it'd be more change at the start.
So it asked so part B was saying the sample of gas in a container at low pressure is steadily compressed at a constant temperature for 10 minutes. Is the volume decreasing more rapidly at the beginning or end? So you're taking this, you are compressing it. Okay, as you compress the gas, obviously the volume gets smaller. Does that make sense? So that's why the derivative was negative. So we're asking, is it going to decrease faster at the very beginning or at the end? So a couple ways to think about it. The thing that's changing here is the pressure. So as your pressure gets bigger, you have a constant divided by a bigger and bigger number. It's turning into 0. Okay. We know, if you're thinking about like horizontal tangent lines, this is going to be approaching 0. When we think about those, they always kind of flatten out, right? So if we have the faster change at the beginning versus the end. Another way you could think about it, you know, if you take like a foam ball and you squeeze it. As you squeeze it at the beginning, it gets smaller, right? It's just going to keep getting smaller and smaller the harder you squeeze it. But eventually, you're squeezing it tighter. Is it getting a lot smaller at the end? No. So the more rapid change is at the beginning than the end. Does that make sense? All right. Economics.
So the first part, you just find the derivative.
So this one was gave us a cost function, asked for marginal cost. Marginal cost just means derivative.
On B, you just plug that 200 into the derivative. Which equals 32. Do you have to write out like the explanation?
You can say it out loud if you want.
Basically means the rate of change per yard made in the cost.
So
for every additional yard after 200 yards, it costs $32 to produce.
right. A marginal cost is not the same as the cost function. It is not saying that it costs $32 to make 200 yards of fabric. Marginal cost is a derivative. It's telling you the change in cost. So when we produce 200 yards, it costs us an additional $32 to make another yard.
And then for this one, it wants you to like figure out the difference, if this number is actually correct, between the 200th and the 201th roll. So you have to plug it into the original equation.
So they're going to find the actual increase. We predicted it to go up $32. Let's find the actual cost of producing 200 and 201.
the cost was the difference was $32.20.
So we predicted it would go up $32. It actually went up $32.20. So was our prediction accurate? Pretty close. Only 20 cents off. All right. Any questions on this one? We've got like 6 minutes. Do you think you can get through your problem?
Yeah.
Okay. More like 6.5 minutes, if you want to be precise.
Sure.
All right. You got that?
First one?
Ours is about fish.
What should I write for that?
So A was what value of the derivative corresponds to a stable population. For a stable population, it would just have to be like flat, so it would just be 0.
No change.
Yeah.
They have this big equation that was given to them. And if you look, it tells you what all the variables stand for, but the big thing, the dp dt is your change in population. So this whole thing is representing how the population is changing. If your population is stable, is it changing? No. So a stable population would be when the derivative is 0. No change.
B was if the pond can sustain 10,000 fish, the birth rate is 5% and the harvesting rate is 4%. Find the stable population level.
Should I
Okay.
write the equation?
So the 10,000 is the population that it can sustain. If you read in the problem, that's the P of C. So they just plugged it in there. The R was the birth rate, so 5% would be 0.05. The beta in the original equation is your harvesting rate, so that's 0.04. We want it to be stable, so they set the whole thing equals 0. So they have this really nasty looking equation. But what they're doing first is dividing by P of T, because they essentially have 2 terms on the left, 0 on the right. So if they divide everything by that, it cancels out one of their P of T's. And that equals
That would be
0. So then they added over the 0.04.
Dividing by the 0.05. And then we subtract 1 from the 0.8.
And that's a negative P of T, right?
Okay.
If you hit that little arrow down on the right side, it'll give you more space.
And then we multiplied by negative 10,000 so that we could keep the P of T positive on the left.
Okay, so what they found is under these conditions, if we're harvesting at a rate of 4%, we have a birth rate of 5%, we can only keep 1,000 fish alive in our pond, we have a stable population when there are 2,000 fish. So if there's 2,000 fish under those conditions, there will not be a change in the population level.
Was what happens if beta is raised to 5%. So we just did the exact same thing as we did before, but raised the 0.04 to 0.05.
So essentially what it's saying is the birth rate and death rate are the same now. Or sorry, the birth rate and the harvesting rate. Now is harvesting rate the same as the death rate? No, because not only are you taking fish out of the pond to harvest, but there are also fish that will die from other causes. So would you think you would find a stable population in this scenario? Probably not. Let's see what happens.
So that equals 0 again.
And then we added the 0.05. And divided by that 0.05. subtract the 1 over. Which gives us 0, and then multiply by negative 10,000, which just gives us 0.
So, did they have a stable population? No, they found out the population would be 0 here, because you're going to have fish dying faster than fish are born, so there will not be a stable population. Okay, any questions there? Okay, we are having a work